today we're going to start looking at the applications of quadratic relationships. So what that means is we're going to be looking at parabolas and equations in relation to a word problem. And this is one of the steps we need to take so that eventually when we go back and shoot our Nerf guns again, we can easily figure out how high our Nerf dart went based on the distance or the time that it traveled. So to do this lesson, you're going to need a copy of the Applications of Quadratic Relationships handout, and you can get this from your teacher. I'm going to work through this handout with you and complete the first couple examples, and then you're going to need to try the last few on your own. You're going to need to pause the video to make sure that you get everything copied down onto your page. So pause it when you need to. I won't give you any prompts to do so. The first application we're going to look at is a word problem about a quarterback in the Super Bowl. And it throws the ball and it tells us that the height of the ball, h, can be calculated using this equation. H equals negative 4x squared plus 2x plus 5. And we know from our work with quadratics that this is an equation in standard form. We also know that if we have an x value, we can substitute it into the equation and solve for h. Our first part of our application is asking us what is the height of the ball 8 seconds after it's thrown. So basically it's telling us that x equals 8. We want to know what h is. So we know that h equals negative a quarter x squared plus 2x plus 5. We also know that to solve, we just need to plug in our x value. So it becomes negative a quarter bracket 8 bracket squared plus 2 bracket 8 plus 5. Plug this into your calculator all in one shot if you have a scientific calculator, and we learn that h equals 5. Because it's a word problem, we have to finish with a therefore statement, and this funny 3 dots is the symbol for therefore. So we're going to say therefore the height of the ball is 5 feet. Next, part B, we want to complete the table of values below, and then we're going to graph our relationship. So all we have to do is substitute in our time value every time you see an x in the equation. We already know from up here that when time is 8, our height is 5, because we already solved it. So go ahead, pause the video now, and calculate the height values for these times by substitution. If you filled out the table of values correctly, you should see that at 0, height is 5, at 2, height is 8, at 4, height is 9, at 6, height is 8. We already talked about how at 8 is 5, and at 10 it's 0. So now you can take these values and you can plot them on a grid. But to do that, we're going to have to label our axes first. So when we're plotting an actual application, we have to label our axis. So we're going to put time down here on the x-axis, and we're going to give it the unit seconds. And we're going to put height over here on the y-axis and give it a unit of feet. We also need to give it a scale, which means we have to put our numbers on the grid line. Usually want your scale to be as big as possible and still fit the grid, but you want it to be easy to work with. So a good scale for this one is just going to be one line is one number, because our scale has to go up to 10 and should go a little past 10. So our height will be the same. So once you have your graph ready, you can actually plot our relationship, just like we've done before. Our first point is at time equals 0 and height equals 5. Our next point is at time equals 2, height equals 8. At 4, height equals 9. At 6, height equaled 8. At 8, height equaled 5. And at 10, the height was 0. Draw your parabola, and you're finished. To finish off this problem, we have 2 questions we need to answer. Very straightforward. Our first question is asking us, what is the maximum height of the ball? We know the maximum height of anything is going to be the vertex if it's a parabola that's opening down. So our vertex, maximum height, the y value of our vertex is right here at 9. So the maximum height of our ball is 9 feet. And it also wants to know how long the ball is in the air for. So we have to look at our graph and we realize that the ball starts in the air here at 0 and at 10 seconds it hits the ground. So it's in the air for all of this time. So we know that it's in the air for 10 seconds. Okay, so we're done our first example that we're going to do together. Flip the page over, we'll do the back, and then you're on your own. So our second example is a little bit different because there's a relationship between how much a ticket is costing and how many tickets are sold to seeing a movie in a movie theater. So basically it says that your tickets are regularly sold for $6 each, and when that happens, an average of 800 people attend. So we can see that right here in our table of values. It's estimated that if you increase your ticket price by $2, then 100 fewer people will attend. So if we want to fill this information in, if you have an $8 price ticket, then you're going to sell only 700 tickets. If you have $10 price ticket, you're only going to sell 600. If you go the other way and your ticket price is $4, you're actually going to sell 900. And if your ticket price is $2, you're going to sell 1,000. So fill in the rest of our number of tickets sold here. Okay, so this is what your numbers should look like. Now, because we know the ticket price, and we know how many tickets are sold, we can calculate our revenue. So our revenue is basically the ticket price times number of tickets sold. So if we have $2 tickets and we sell 1,000 of them, then we're going to make $2,000. If we have $4 tickets and we sell 900 of them, then we're going to make $3,600. So calculate the rest of your revenues for the ticket price. It correctly, these are the numbers that you should end up with. The question is now asking us to graph the relationship on the grid provided. So just like in our first example, we have to take our grid and we have to label our axes and add a scale. So we're going to put ticket price on the x-axis. And our unit is in dollars. We're going to put revenue on the y-axis. Both of our axis labels need units. They're both dollars and they both need scales. So pick a scale that's easy to work with that is going to let you plot all of your data. So once again, if we go up by 2's, on every other line, so we're really going up by ones. We will get everything we need plotted. And if we go by up by $1,000 on the y-axis, on every other line, we'll get in all of our numbers that way too. Okay, that's a little messy, but you can still read it. So now you need to plot your data points just like before. Okay, so at a $2 ticket price, there is a $2,000 profit. A $4 ticket price gives a $3,600 profit. A $6 ticket price gives a $4,800 profit. An $8 ticket price gives us a $5,600 profit. A $10 ticket price gives us a $6,000 profit. So does a $12 ticket price. 14 gives us a 56. A 16 gives us 48. 18 gives us a $36 ticket price. 20 is a $2,000 ticket price, and a $22 ticket gives us a revenue of $0. Okay, then graph your parabola. It needs to come a little bit above the $6,000 mark. It's messy, we'll fix that up. Because we know the vertex is just above, just in between the 6,000 here and the 6,000 here. Okay, that's a little bit messy. It's a little bit tricky on the iPad, but that's what your graph should look like. Okay. And then it's asking us, what price should the tickets be sold to maximize revenue? Okay. And this is pretty simple because we know up here the maximum revenue is between $10 and $12. So they should be sold for $11. That's where our vertex is located. Okay, so the rest of your task is to work through the rest of this booklet. The next page has some graphs already written for you that you just need to analyze. And then there are a couple examples that you have to complete the table of values, graph the parabola, and answer a couple questions. This needs to be finished today. If it doesn't get done in class, it is homework. In our next class, we're going to move on. We're going to talk more about applications of quadratics. So get a little bit more challenging. We're going to go try to answer our questions straight from an equation without having to graph our parabola. And then we're going to go back to those Nerf guns in the cafeteria and see if we can figure out how high they're actually shooting based on the distance that they travel horizontally.